So hopefully you have yours sitting in front of you. So here it says determine. Ready? Determine which of the following are factors of this fourth degree polynomial. Now, I'm not asking you to use the rational root theorem on this. I'm giving you possible factors here. So what you're going to do on your calculator, yeah. I made two of them. I knew it. I've asked like 3 times. Anybody else gonna need one? And I made 2 because I've been teaching for 19 years. All right, so here we go. As we go through these, what we're going to be doing on your scientific calculator or in your head, okay, scientific calculator in your head, is plugging in the opposites of these, right? So you'd plug in 3 here. Do you get 0 when you plug in 3? Okay, so then you get to do a double check here. You take 3, and you are going to synthetically divide it into this thing. Bring down the 2. 3 times 2 is 6. That's 9. 27. -6. -18. -5. And there's my double check, right? I get a 0 in the remainder. So yes, 3 did work. That's the cool thing about the synthetic division is even if you messed up and plugging it in, even mentally, you do a double check. So there it is. With what I'm left, so there's one factor. I then, on this one, I would just move. This is not suggesting that any of these are double roots. So I would move to the -2. Does -2 work? No. I moved to -5. Did you find that -5 worked? Okay. So it looks like -5 works. We take -5. We synthetically divide it into the 1 degree lower polynomial here. So this is an x-cubed polynomial. So bring down the 2. It's -10, -1, 5, -1, 5, 0. So there it is. It does go in. So I'm circling that one. And then somewhere amongst these next 3, a couple more work. You have a couple choices here. You could keep doing synthetic division if you like that. You could try then the 1 in there, and then the 4, and then this would. What would you be trying in here? -1/2, yeah. -1/2. Because remember, it's the opposite sign of what you see in here. But I think this is not hard to factor, right? So it equals 0, and then you find the other 2 zeros. You don't even need to set it equal to 0, but factor it. What do you end up with factors for this? I don't think the x minus 4 is involved. So the other 2 factors are, I'm going to say x minus 1 and 2x plus 1. Is that correct? No? Doesn't work. That would have meant that I listed factors that don't work up here. So there it is. So that's just helping you to understand the relationship between zeros and factors. Find the rational zeros. When I tell you find rational zeros, I'm telling you use the rational root theorem, and then within that rational root theorem list, all of them are there. Okay? In other words, you're not going to have any with i's attached. You're not going to have any with square roots attached. So according to the rational root theorem, which says you take r over s, all of its factors, we would have plus or minus 1 plus or minus 2 over plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 6. Okay, so those are the combinations. You do end up with a lot of fractions in here, which would be a reason maybe to try the ones that are not fractions, get it down to a quadratic and then factor. It's probably easier to factor, but it's up to you. We could go through the whole list too. So I have as a possibility plus or minus 1, plus or minus 1/2, plus or minus 1/3. I'm just taking the 1 and placing it over each of the numbers on the bottom. Plus or minus 1/6, and then take the 2 and place it over each one. Plus or minus 2. 2 over 2 would be 1. I already have that. Plus or minus 2/3. And then 2 over 6 would be 1/3. I already have that. So what I would suggest is that you try 1, -1, 2, and -2. Those 4. And hopefully among those 4, we have 2 that work, bringing it down to a quadratic. That's how I would approach it. So does 1 work?
Yeah.
Oh, convenient. So 1 works. So we've got 6, 1, -8, -1, 2. Bring down the 6. 7, negative 1. Okay, so 1 is one of those. Now, when I'm asking for zeros, you don't need to go and write it in factor form. I'm just asking for the numbers that make this polynomial equal 0. So one of them is 1. I could try 1 again. It's a possibility there could be a double root. It doesn't work, though. Does negative 1 work? Negative 1 works? So then we would go ahead and what you can do is once you've tried negative 1 on your calculator or in your head, you've gotten a 0, go ahead and just place another little synthetic division step here with this guy that's already here. So bring this down, bring down the 6, it's negative 6, and it's negative 1, that's negative 2, 2, and then that's 0, so there it is. So 1 and negative 1 work, that's convenient. So we have zeros of x equals 1, negative 1, and we're going to find 2 more of them. Right here, I have the quadratic equation 6x squared plus x minus 2. Set that equal to 0. Can I factor that and get the other 2 zeros? I believe the other 2 zeros are fractions. I don't think 2 or negative 2 work. So what are the factors here that work? You think it's 2 at, what is it? I think this is factorable, so we should. Yeah, we're on number 2. Okay, so we go over here, we do our little, factors of negative 12 that add to equal 1. Do they exist? Yeah. And 4, negative 3 and positive 4. And then we divide through by what? 6. And then we reduce each of these. This one reduced is 2 over 3. So that tells us one of the factors. This one reduced is negative 1 over 2. So using our little bottoms up, or whatever you want to call that, where you find factors of a times c, 6 times negative 2, or negative 12, that add to equal the middle term 1. They exist. 4 and negative 3 multiplied equal negative 12, add to equal 1. You divide through by a, and be sure to reduce it. If you don't reduce it, you won't have the correct factor. So bring the bottom up. We call it bottoms up because this bottom comes up with x. So 3x plus 2. And then 2x minus 1 are my factors. So that would lead to 2 other zeros. Can you do it in your head here? What would make this 0 here? Yep, move the 2 over. It's negative 2 divided by 3, so negative 2/3. And then 1/2. So those are your 4 zeros. You could have gotten them by just trying every one from that list. You would have eventually gotten there because I told you they were all rational. No reason. Right, this one says find all the real zeros. What does this word real imply, maybe? Okay. But I didn't say rational. So what's the difference? Well, rational, they could all be fractions. There's going to be something else involved in this. What's that? Okay. This is good. Well, this is good theory then to understand. Rational zeros means they're all fractions. There's no square root signs in them. Real zeros means you could have a pair that have square root signs as part of the answers. Okay. It doesn't say complex, so there won't be i's. Don't expect i's in any of these. Okay, this is good stuff to think about as you go through the test. Then you know what to expect. So here, I'm thinking that there could be some with square roots in them. Okay. So let's see what it looks like. My possible factors would be all the plus or minus factors of 16 because this first number is 1. So there's a lot of them. Does 1 work? Yeah. 1 works? I'm hearing different ones. Does 1 work? You tried 1. We could try it right now. 1 minus 2 is negative 1, minus 8 is negative 9, plus 16 is not 0. So 1 doesn't work. 2 works.
Does negative 1 work?
What do you think? Well, that would be negative 1. This would be minus 2. That would be minus 3, plus 8, 5. No, I don't think so. At least whisper. I heard that 2. I heard a rumor that 2 might work. So I'm gonna take a chance and go straight to synthetic division and just hope for the best here. So bring down the 1. 2 times 0 is 0. That's a -8, -16, and no. It works. So here's what that means. I've got a 0 at x equals 2, and then I've got 2 more of them. And the 2 others can be found by solving x squared minus 8 equals 0. It's kind of like what was happening in that quiz, except instead of 2 here, it's an 8. So we move the 8 over, and we take the plus or minus square root of 8, which simplifies to plus or minus 2 root 2. So my other 2 zeros are plus or minus 2 root 2, and they did have radicals, just as we expected. Okay? But we take that x squared minus 8. Now, if there was a middle term here, you'd have to use the quadratic formula. I don't have to use the quadratic formula because I can solve by taking square root of each side when there's no x to the first in. Okay? So if there's a middle term here, if it's not 0 here, you will have to use the quadratic formula, and I may ask you to simplify it. If it's a multiple choice, you'll have to simplify it to get the match up. So any questions on 1 through 3? So we're kind of building here. Rational zeros, real zeros. I think we take a segue for a moment. Yeah, so now we're going to build a polynomial before we get to the find all real zeros. So this says generate a polynomial function of degree 4, oh boy, with zeros of 2 and 3 plus I. The 0 of 2 should have multiplicity of 2, so x minus 2 squared. And then the other 2 zeros, if 3 plus I is a 0, we have x minus 3 plus I. Then 3 minus I is also a 0, so we have x minus 3 minus I. And when I multiply this out, I should get a quadratic trinomial. So you know what to expect. A quadratic means x squared, trinomial, 3 terms. So I should have a quadratic trinomial. That means the I terms should all cancel out. Okay, they should cancel out. Doing it correctly. This is a perfect square trinomial. You can apply your shortcut, square the first, multiply these 2, which is negative 2x, and then double it. Square the last. So there's that quadratic. And then this one, might want to take a couple steps on this. I've got to distribute. I would, just to be safe, distribute. Then distribute just the minus sign. Just to have it there before I try and get all 9 terms that you're going to get right here when you distribute. Because if we miss a sign, we're in trouble. So watch as we go through this. You can be my editors here. So I'm going to have 9 terms. X times x is x squared. X times negative 3 is minus 3x. X times I is plus xi. Negative 3 times x. Negative 3 times negative 3 is plus 9. Negative 3 times I is negative 3i. And then negative I times x is minus xi. Negative I times 3 is plus 3i. And negative I times I is negative I squared. And I still have this x squared minus 4x plus 4 here. So, okay, negative 3x. So I'm expecting the I terms to cancel out. Those do. These do. And then this right here is equal to negative 1. And negative 1 will be positive 1. So because I squared is negative 1, and there's a minus sign in front of it, I will end up with a positive 1 there. So my 3 terms are x squared minus 6x. 9 plus 1 is 10. So if you got to that point, you're well on your way. You're doing well so far. I will, like in partial credit, I will be looking for this polynomial. So it tells me that you understood the correct zeros here, if you get that. So then I get 9 terms now, no i's in them. So x squared times x squared is x to the 4th. X squared times minus 6x is minus 6x cubed. X squared and 10 is 10x squared. Minus 4x to the third, x squared, minus 24x squared. And then negative 4x times 10 is minus 40x. Now move to the 4. Plus 4x squared minus 24x plus 40. And then I've got to combine like terms. So I've got an x to the fourth, I know. This is my final answer. X to the fourth. Take care of that. I've got a negative 6x cubed, a negative 4x cubed. There's negative 10x cubed. Is that it? So negative 10x cubed. Does that look okay? I didn't miss any here or mess up on a power. And then do you see, how many x squared terms do you see here? There are 3 of them. Okay, so negative.
Wouldn't that negative 24x squared be a positive? Because it's negative 4 and negative 6.
I think it is, yes. Negative 4 and negative 6 here, it should be a positive. Good catch.
Check.
Anything else on there you see before we? That's an easy fix. So, yeah, so we've got. Oh, that's coming. This is coming later. So 38. I'm hearing 38x squared. So, yep, that looks correct. Plus 38x squared, and then negative 40x. Put a squiggly under this. So it's negative 66x. Did I catch all of them? 64x, yep. And then plus 40. We did it. So there it is. Good. But yeah, we'll have to, even as you do it, you're going to have to really check your signs, maybe double check the distribution. You'll have more room on the a little more room, or write on another sheet of paper, that helps too. All right, number 5. It says for the polynomial, by the way, what's the degree of this polynomial?
1.
That's 1. This is 3 more. We're up to 4, 5, 6. So it's degree 6. What are the real zeros? Well, I've got a 0 at 0, yeah. Negative 2 and 3. So 0, negative 2, and 3. It's okay. Negative 0 and 0 are the same place. Does the graph touch or cross? So this time, what about at 0? Does it cross? What about at negative 2? And then at 3 it touches. Okay. Will the end behavior be same or opposite direction? Same, because it's degree equals 6. Determine the max number of extrema. That will be 6 minus 1 or 5. Okay, so draw the graph. We've got zeros at 0, negative 2, and at 3, and it just touches at 3. They'll be going in the same direction. Are they going both down or both up?
Down.
Down because of the negative sign here. Okay, so I think we have enough information. So in the end, they're going to go down. So if it crosses through negative 2, it's going to cross through 0, and it's just going to touch at 3. So that's a rough sketch of what it could look like. All right, now number 6. This is one that's dealing with all zeros, so they could have i's attached. As a matter of fact, I tell you 4i is a 0, so that means negative 4i is a 0. And so that would mean x plus 4i times x minus 4i is a quadratic that will divide into this. And we're going to need this quadratic to divide into this to bring this 4th degree polynomial down to another quadratic. So when you multiply these together, you'll find that you get x squared plus 16. The middle terms cancel out. Now, I can't use synthetic division on this. We've got a quadratic. What I need to do is long division with a placeholder. So it's long division with a placeholder here. Okay. If you take and distribute here, you get x squared minus 4xi. Okay. You write that all out. Alright, and then here we've got x to the fourth plus 2x cubed plus 13x squared plus 32x minus 48. Let's get it started here at least. Don't forget your placeholder. X squared goes into x to the fourth. 1x squared times. Distribute the x squared, you get x to the fourth plus 0x cubed plus 16x squared, and then we're going to put parentheses around that and subtract it. No, I didn't give you enough room. So subtract it. We get 2x to the third minus 3x squared. Bring down the 32x. And then go through the process again. X squared goes into 2x cubed. 2x times. And then we have 2x cubed plus 0x squared plus 32x.
Thanks, Eric.
And then subtract. So looks like we just have negative 3x squared. We have to bring down the negative 48. And so that goes in minus 3 times. That's negative 3x squared minus 48. When I subtract that, I will get 0. Get 0 there. So here's what we end up with. We've got 2 zeros. We've got x equals 4i, negative 4i, and then we're going to get the other 2 by taking this quadratic x squared plus 2x minus 3 and factoring it. So if you take x squared plus 2x minus 3 and factor this thing right here, what do you get? It's going to be x plus 3x minus 1. It's a pretty easy one to factor, right? Set that equal to 0. So my other 2 zeros from the factors of what's left over would be negative 3 and 1. So the other 2 zeros are actually rational. You could have, using the rational root theorem, just gone through the list too to find them, but that would work. You didn't have to go too far. Could get ugly if it were, 44, yeah, or 16, 24. So, but anyways, also an option. Although it could have been the case that the other 2 were also complex, so hard to say. All right. Number 7, it says find all zeros. So when I say all zeros, I mean complex. It could be complex. They could all be real, but most likely I would ask for all the real zeros if they're all real. So find all zeros. Here we go. We're going to try plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. What's the first one that worked? 1 worked? Okay. Oh, that's convenient. 1, negative 1, 1, negative 11, and 10. So bring down the 1. So here's what we have. We have this x cubed plus 0x squared plus x minus 10. So one of the zeros is x equals 1. All right. We could try 1 in here. That'd be 1 plus 1 minus 10. That's not going to work. So 1 doesn't work there. What about negative 1? Does negative 1 work?
2 works.
Or negative 1 doesn't work. 2 works, huh? So we just go again with 2. Let's see what happens here with 2. So here's our double check. That's 5. Looks like it's going to work. There it is. So 2 does work. So 1 is a 0, 2 is a 0. And here, it looks like we have x squared plus 2x plus 5. Set that equal to 0. That's not factorable. So we're going to have to use the quadratic formula. It says x equals opposite of b, so negative 2 plus or minus square root of b squared, which is 4, minus 4 times a is 1, c is 5, all over 2 times 1. This simplifies pretty nicely. 4 minus 20 is negative 16, right? 4 minus 20 is negative 16. So I end up with negative 2 plus or minus 4i over 2. The radical completely disappears, thankfully. 4 minus 20 is negative 16. Square root of negative 16 is 4i. And then if we simplify this, what should we get? This is a negative 1, yeah. Plus or minus. Don't forget to take the 2 into both. And I have all 4. Alright, we got some more multiplication to do here. Oh boy. That's okay. Boy. So create a polynomial. Here's what we're going to do. If it crosses through once, we're going to assume just one factor. If it touches, we're going to assume squared. And that's it. We don't want to be doing any more than that. So we are going to minimize it. So right here we've got a negative 2 is a 0, so x plus 2 is a factor. Here it goes through 0, so that means x is a factor. If you wanted to, you could write x minus 0. So I've got one here, one here. It crosses through at 1, so x minus 1 is another factor. And then here it just touches at 1, 2, 3. So that means x minus 3, we're going to say squared. It could be any even power, but squared for our purposes. So this is finding a possible polynomial. It's not unique. Well, because it just touches right here. If it just touches, that means it has a multiplicity that's even. And I'm choosing squared because I don't want to choose fourth power. So here I've got x squared plus 2x so far, times x minus 1. And I could probably square this out. X minus 3 squared is x squared minus 6x plus 9. That's a perfect square trinomial. I'm going to distribute here. That's x squared times x is x to the third. X squared times negative 1 is minus x squared. 2x times x is plus 2x squared. 2x times 1 is minus 2x. And I've still got this guy over here, x squared minus 6x plus 9. Looks like I can turn this into a trinomial. X cubed plus x squared minus 2x. And I'm going to multiply that by x squared minus 6x plus 9. Oh boy, so here we have 9 terms again. Help me watch the powers. Here we go. We can do it. X to the third and x squared is x to the fifth. So we'll carefully do this. X to the third minus 6x is minus 6x to the fourth. And then x cubed plus 9 is 9x cubed. And then move to the x squared. X squared and x squared is x to the fourth. X squared minus 6x is minus 6x to the third. X squared plus 9 is 9x squared. And I think I hit all of them. So negative 2x times x squared is minus 2x to the third. Then minus 2x times negative 6x is positive 12x squared. And then minus 2x and 9 is negative 18x. So move this out of the way. No, let me move it. Okay. Right, can't move any of that. So I'll do it in a different color. So this equals x to the fifth. And then I've got a minus 6x to the fourth. So there's minus 5x to the fourth, it looks like. Minus 5x to the fourth. Move this down here. So minus 5x to the fourth. And then I've got 9x to the third, minus 6 is 3x to the third. This is an x to the third. Make sure we can see a third on here. So So I think all the squiggly ones, I catch all of them. So 3 and then minus, so minus x to the third. And then 12x squared. 9x squared is 21x squared. And then minus 18x. That's a polynomial. All right. Then we move into asymptotes and holes. So we'll finish up with these and then we're done with our review. I'm done with the review. You can come by tomorrow morning and see me. I'll be here at 7:30. So find the equations of all asymptotes and locations of any holes for a function. I usually just start with the vertical asymptotes. Well, I start with factoring. And then as soon as I factor and cancel, I can identify the vertical ones. The vertical ones are probably the hardest to find, in fact, vertical or oblique. But here I have, if I factor out an x, I'm left with x squared plus x minus 12, which factors further, x and then x plus 4, x minus 3. I feel like we've done that already today. And then here, this would be x minus 6, x minus 3. So x minus 6, x minus 3. So we factor first. So hopefully we're okay with factor first, top and bottom. And then we're going to cancel wherever we can. So those x minus 3's cancel out, leaving x times x plus 4 over x minus 6. So my vertical asymptote, I can get that right away. The vertical asymptote is whatever would make the bottom 0, but does not get canceled out. Okay, so x minus 6, set that equal to 0, x equals 6 is my vertical asymptote. Got my vertical asymptote. My hole, the x-coordinate of my hole, would be at 3 comma something because x minus 3 equals 0, x equals 3. The something comes from plugging in x equals 3 in here. Okay, you got to plug it in there. So it looks like this. I've got 3 plus 4 over 3 minus 6. And that gives me 21 over negative 3, so negative 7. So I have a hole at 3 comma negative 7, so I know the exact location of that. So there's the second part. And then the horizontal asymptote doesn't exist because the degree of the top is bigger than the degree of the bottom. So there is no horizontal asymptote, meaning there is or could be, I should say is, but there could be an oblique. There is an oblique because the degree of the top is only 1 more than the degree of the bottom. Remember, the oblique asymptote will be a linear equation. To be a linear equation, the degree of the top can only be 1 more than the degree of the bottom. And you've got a long divide, but we can long divide with our simplified version over here of our rational expression. As a matter of fact, we could synthetically divide to find it. So I'd have a 6 here, and what would the coefficients of this quadratic be? We'd have x squared plus 4x, so there would be a 1 here and a 4, and then there is no constant, so I could place a 0 on there. But that's what this would be if you multiplied it out, x squared plus 4x. Bring down the 1, 6 times 1 is 6, that's 10, 60. We ignore the remainder and just look at the linear equation that's left over. So my oblique asymptote is y equals x plus 10. The vertical asymptote has 1 hole and then an oblique asymptote. Alright, so let's see if we can do the same process on this one. Now this will differ a little bit. See how the degrees are the same? So the horizontal asymptote, you can pick it off right away. It's going to be y equals something always. So y equals, it's not 0. If this were a 2 and this were a 3, it would be 0. It's y equals 0 if the degree of the top is less than the degree of the bottom. If they're the same, you take the leading coefficients and reduce them. So it's y equals 1/3. Y equals 1/3. Now to get the rest, we're going to need to factor. So back over here, let's factor this guy. We can pull an x out. How does x squared plus 2x minus 3 factor? That would be an x plus 3, x minus 1. So there are the factors on the top. This one, pull out a 3x. X squared plus 3x minus 4. I might need to write that down. X squared plus 3x minus 4. How does that factor? How does this guy factor here? The x plus 4x minus 1, okay. Which is not a surprise. So x plus 4 and x minus 1. So we do have some things that cancel. We have an x that cancels. We have an x minus 1 that cancels. So that tells me that there are two different holes. One, when x is 0, comma something, and another when x is 1, comma something. So here's my new rational function. The x's divide to equal 1. I have an x plus 3 left on the top, a 3 on the bottom, and an x plus 4. If I plug in 0 here, plug in 0 for x. 0 plus 3 is 3. 0 plus 4 is 4. I get 3 over 12, which is 1/4. So I get 1/4 as the y coordinate to go with 0. And then I'm going to plug in x equals 1. This was x equals 0. Now plug in x equals 1 here. So I have 1 plus 3 over 3 times 1 plus 4. So I get 4 over 15, it looks like. So this y coordinate is 4 and 15. So I've got both of my holes. I've got my horizontal asymptote. I can just look at this guy right here, my reduced version of it. Look at the bottom. What would make the bottom equal 0? If x equals -4, the bottom equals 0, so that's my vertical asymptote. So vertical asymptote is whatever can't be factored out. You set that thing equal to 0, or things, it can have be multiple. And those are your vertical asymptotes. So that's it.